Hello, and welcome to another exciting Breakfast with Unity. I'm your host, Max Moreau, and today we're going to be animating our recursive tree that we worked on last episode. Our last episode, and I'm just going to continue this in the same project, just because it's just a continuation of what we were doing. If we hit play, we get a little tree, and the tree is randomly generated using recursion. And yeah, it kind of looks like a tree. This was a little bit lopsided, but that's okay. Lopsided trees are cool too. And today what we're going to do is we're going to try and animate this thing a little bit, kind of simulate wind. And I've only done a portion of this as a test, so we'll see how good we actually make this thing look. So we're going to start with just trying to get it to animate, like in any way. We're going to just use some quote-unquote Brownian motion for this. And then we'll see how that looks, and then we're going to try and kind of coax it into being more wind-like. So first off, what we're going to need to do, this is not the right project. Let's open this up. Got so many versions of MonoDevelop and Unity at this point on my computer, just for different project reasons. What did I do? Okay, where is it? Thank you. So, the first thing we're going to need to do is something simple, but there actually is a problem here, and I actually can't describe why this is a problem. We're going to want to parent the objects so that the root of this, when we hit play right now, these aren't connected in any way. So they move completely separately. Like if I move the root, nothing changes. But we want, when we're animating, we want everything to kind of rotate from their roots and stay in the position that they're in. But if the root underneath them moves, they need to move with it. So we can do that by parenting. But I ran into a problem, and I'm going to show it here because it's interesting to me. We have this instance. We can totally parent it right here. We can just do instance.transform.parent equals transform. And this should, in theory, work. However, when doing this in start, when we're generating more of them, for some reason this causes some sort of crash in Unity. I'm going to show it right here. So we're going to just hit play, and it's going to crash. Yep, there we go. That's all she wrote. And so I had to figure out, I had to do a small workaround to actually make this work. It's not a big deal, but it's kind of interesting to me that there's a problem. I think it has something to do with the way that it moves the transforms when doing it, and because we're doing it in a recursive fashion, it's basically moving the transforms, and then it thinks it has to move the transforms again, and it thinks it has to move the transforms again way more times than it needs to, probably an infinite amount of times. At least that's my theory. So I'm going to quit this, and we're going to go back and fix that. All right. So what is it called? Unity. Breakfast with Unity. And what we're going to do is we're going to change where this is at. So we can't do this. So we're going to have to keep track of our children and then parent them later. So I'm going to create a couple of private variables. Actually, we're first going to need system.collections.generic so that we can have a list. We're going to create a private list transform child list equals new list transform. So this creates our list and initializes it as empty, and then we're going to create a private bool has parented. Actually, let's call it done parenting. You're never done parenting, but this one will be. So, and we'll just make sure that it should default to false, but I'm going to explicitly say false. So, in update, what we're going to do is if not done parenting, we'll do some stuff there. And in here, what we're going to do is just simply add instance.transform to our child list. So child list dot add instance.transform. So now we have a list of our children, and then in update, the first time that we run update, we're going to go through the list and add them to our change their parents to this transform. So for each transform child in child list, we're going to do child.parent equals transform. And then finally, we need to set done parenting to true so that we aren't doing this every frame. This will just be done once. So if we hit save now and hit play, it should work without crashing this time. Hopefully. There it is. And you can see now that we have this twig, and underneath the twig we have 3 twigs. Remember, we've got this set to... what do we got this set to? We've got this set to 3 splits, so each one will have 3 splits, and we've got 5 iterations, so this should be 5 deep. And there we go, it's 5 deep. So, actually it's 1, 2, 3, 4, 5, yeah, good. Alright, so now we have them all set up, and so now if we move or rotate one, it will affect the rest of them, which is great, because that means that when the individual things start moving, it'll be nice. So... obviously, we've got some branches going through stuff. We're not going to deal with tree collision stuff. That's ludicrous at this point. So there we go. And now we're going to make it so that these things move. And as I said, we're going to start with the most basic way to move them, which is just random movement, which would also be called Brownian motion. We're just going to pick a random direction and start moving towards it. And so what we're going to need is public float... wind angle. I'm going to make this, we're going to do just like 10 degrees to start. That's probably way more than we should. And public, actually, yeah, that'll be fine. Public float and wind angle. And we're going to do something very similar to what we're already doing up here. What we're going to do is we're going to take this calculation here. We're going to change a couple variable names. So we're going to use, instead of spread angle, we're going to use wind angle. And what else? That's it. Let's just see how that does. And then instead of twig rotation here, what we're going to do is we're going to just do transform dot rotation equals, there we go, save. So if we hit play, we should have a little bit more of a animated tree. A crazy animated tree. So I told you that we probably did way too much. Actually, if you've ever played folding at home, or if you've done protein folding experiments and stuff, this is what it kind of looks like. It also looks like we're breaking things pretty bad. If I pause this, yeah, that's not going so good, is it? I don't know why our tree is completely disassembling itself, but it appears to be. Let's see what we're doing here real quick. So, rotate towards range, wind angle. We have everything parented. Here, let's make the amount smaller so we can see what's going on. Let's make the wind angle 1 degree. Okay, it's freaking out. So I think, okay, I know what's wrong. Wait, I don't know what's wrong. Well, first let's just make it so that this only goes, we multiply in time.delta time. So this will make it much shorter. It'll be like 1/60th of the amount. Let's see how that looks. I don't know why they're breaking. Wow, they're really broken. But they're broken a lot right at the start. Maybe they're not done parenting somehow. Oh. So, yeah, some of these are probably 1 frame behind. So, what we're going to do is else. And that's actually not going to be good enough either. Let's find out. I swear this is exactly how I did last time. I didn't have this problem, but Obviously, it's not exactly the way I did it last time because it's different. So, wait, what was that doing? Why is it only rotating around that? Look, rotation, random. Oh wait, current rotation. What's current rotation? Okay, so we don't want to use current rotation at all. We just want to use. Wait, current rotation is transform dot forward. Let's just use the current transform dot rotation here. Save. There, that's much better. Let's see if it still disconnects itself, though. I bet you if we have it really high, it'll disconnect itself at the start, but then it'll kind of be okay after that. Yeah, so it's all it's all messed up. So all right, so at this point, it shouldn't be a big problem with the way we have it set up. So now you can see that we have kind of what you'd expect more for a wind look. Let's zoom in here and see how they're doing. So it looks like it's got a little bit of wind. Oh, we've got self-shadowing and stuff. That's cool. I forget all the cool stuff that we just get in Unity now for free. Well, not for free, you know, not programmatically for free, but like free as in free beer. So that actually kind of looks better than it did when I was testing it earlier. So we've gone from looking worse to when I was testing it earlier to looking better than when I was testing it earlier. So I'll take it. Let's make this a bigger angle and just see what happens, just to kind of get a feel for it. Yeah, it doesn't look terribly bad. Now the problem with this is eventually the tree will. So Brownian motion is random, right? And so it tends to kind of stay where it's at just because every direction is random. But eventually it probably won't be very random. And as you can see, if I crank this up, you'll get situations that there's a lot of wind here, but it's going to slowly deform the tree. And even if we bring the wind back down, like in real life, if wind dies down, the tree would be in a relatively similar position than it started. But now the tree is just going to sit there. So like if we have zero wind, quote unquote, we're going to still be randomly moving? That doesn't... Oh, wait, yeah, we didn't apply it to the children. Okay, so we're only adjusting the base node. That's the problem here. And we actually can't adjust the wind in real time on one thing here because it doesn't affect everything here. So yeah, but basically it'll eventually get deformed because of this. So what we want to do is we want to prevent that, and then also kind of give a directionality to the wind. That's what we're going to try and finalize here on here. So so the first thing is we want to. So we had it before. We're going to need an original rotation. So we're going to create a private. Let's do quaternion original rotation. And we will just, in start, we'll set original rotation equals transform dot rotation. And so now if we use original rotation rather than transform dot rotation, this should make it so that our wind will never completely break the tree, but it'll also make it look a little bit twitchier, as you can see here, because what's happening is it's only moving a very small amount based on the wind angle. I'm going to, again, actually I'm going to hit apply here so that the wind angle is considerably larger. Let's make it even larger. Apply. All right, so that's a good example. So we're using a large value, and the tree is moving, but it's not going to move away from its original position. It does seem a little twitchy right now. So what we're going to do is we're going to try and remove the twitchiness by kind of giving it more of a direction. As I said, I haven't actually tried this yet, so we're going to both see how this, both, like me and the other viewer. I imagine there's going to be more than one viewer. I don't know. Maybe there's no one. If I hit play at 200, oh, that was a nice tree. So yeah, we got this really insane wind looking stuff here going on. And it's because it just is randomly choosing a direction, going a pretty decent spec in that direction, and then randomly choosing another direction and going in that direction. And when I say, so basically we're just like bam bam going away from things. So so let's try and create a directionality to it. So one way we can do this is we can create kind of a global random wind direction by using a static variable. So we're going to create a private static quaternion. I'm going to call this goal rotation. And what are we going to do? Let's create a couple more variables. Let's do public float min wind change time equals let's do 1.0 f public float max wind change time equals actually let's do 1.0 f here as well. Let's do min 0 and then max 1.0. So this will be pretty tremulous wind at first. No, let's do it. Let's do like 1 and 2. 1 and 5. We'll tweak these later. I just want some decent default values, and I think that'll be pretty decent. All right, so when the wind changes, so we are going to create I'm going to create a little function called wind change, void wind change. And what this is just going to do is it's going to do something similar to this. So we're just going to create a random rotation, and yeah, that's not going to be so great, is it? So yeah, let's try it anyway. So let's just create, we're just going to play with this and see what happens. So we're going to change goal rotation equals random rotation. Everything's going to try and rotate towards it, which is going to... So if the wind is actually in a cardinal direction, like a two-dimensional direction from the tree, it'll look right. Well, except for the branches that are below that cardinality. Yeah, this isn't going to work, is it? What's the best way to fix this? So we shouldn't do random dot rotation. We should actually store this as not a quaternion. We're going to store this as a vector 3. We're going to have a wind vector. And that's the same problem. So our problem is, let me just try to describe what we're going to run into here with what I had thought we were going to do, and then I just realized it's not going to work too well. If we... let's say the wind is this way, like just straight up this way. It'll be great. This tree would work perfectly if the wind was going that way, because all of the branches will try to bend in that direction. But the problem is, if the random direction ends up like straight up, what will happen is it's not really a wind, it's a goal. So what happens is everything is going to try and rotate into that goal. And so the tree is going to like try to fold in on itself rather than look like a tree that's actually being blown by wind. Though I guess if the wind was going straight up, that would be appropriate. So yeah, let's just try it. Let's just try it, actually. And we'll just do the random first, and then we'll try and give it a cardinality so that it actually looks like wind blowing by, because wind usually doesn't come up directly up a tree's skirt. So, and wind usually doesn't come directly down either because the Earth kind of keeps that from happening. So you're going to have wind going across the tree. So let's just start with this and see what happens. So we have a goal rotation. We're going to rotate towards the goal rotation now. I'm going to comment this out because we might want to add some randomness to it as well. And then wind angle, times time to the time. I'm just going to leave that. And what else? So we need to call wind change. So wind change really only needs to be called once, but we're going to call it once per child right now. Oh yeah, that's a problem. Okay, so how do we call wind change only once? I know what we're going to do. We're going to create a private bool root. And the root is going to be set to true. And then in here, what we're going to do is instance. We're going to have to make it public. So public bool root, and I'm going to hide this in inspector, hide in inspector. So public bool root equals true, and then instance.root equals false here. So this will mean that we only have one root, and then wind change if root, then we do this. Otherwise we don't do anything. Actually, that's dumb. We'll just say if root in here. We will do a invoke wind change, and the delay will be random.range min wind change time max wind change time, and then additionally we want to invoke wind change once right immediately so that we have a random wind. So we will invoke wind change after this time, and then we're going to copy this and make sure that it re-invokes itself after each time, so it repeats. We're not doing invoke repeating because this allows us to change the actual time between times. So each time we'll have a different random time as opposed to just choosing a random time once. And let's see how this looks. Save. Play. Alright. So it still looks a little twitchy, and I think that's because we're doing a really heavy wind angle. So let's actually set this to a much lower angle. That's too low. Still kind of twitchy. I don't understand why it wouldn't end up at the goal rotation. If we were doing really hard, you would think that it would get to... Well, that's showing our bug still. I actually don't know why it's twitching at all. Oh, I know why it's twitching, because each of these is running a script. So one's moving a little bit, and then they have to move back into position, or they feel like they do. See, I have no idea what I'm doing. We saved this, right? Yeah, we saved this. It's definitely doing kind of... You can see that occasionally it changes direction. I'm going to look at it from the top. Let's take a look at this thing. Let's visualize our wind direction too. Let's do a void on draw gizmos. Actually, we can just do it in here. if root what is it called? Debug.drawArray. Yeah, drawArray. Start is transform dot position. Direction is quaternion dot. That creates quaternion. I want to convert a rotation to a. I guess we'll just do goal rotation times. I might have to do this in the other order, but we'll do transform. Wait, so goal rotation times. I think it's just transform.forward. Because quaternion identity looks forward, so let's see. Oh yeah. Save. Alright, well, that was the right order. Let's see if this actually draws anything. There we go. So there's our wind direction. This is probably not going to work very well, but let's try transform.local rotation just to see what happens. Yeah, that caused some problems. Alright. Rotation. Oh, shoot, it's been 30 minutes. Okay. We're trying. We're working through it. This is how problem solving works sometimes. Sometimes problems don't get solved immediately. So what I think is the problem right now is this script is running first and rotating this one. And then the next one's rotating, and then the next one's rotating. So basically they're trying to counteract their rotations. Now that doesn't explain why the bottom one is shaky. Why would the bottom one be shaky? So if I just did equals goal rotation, I guess I'm curious. Save. Yeah, that's kind of okay. So obviously I'm not drawing my wind vector right, because you can see that thing's Alright, so our debug drawing is not helping. It's kind of interesting, though. Let's try not using the original rotation just to see what happens. That's actually kind of really cool. I'll have to. That's actually kind of awesome. But I just realized there's a big problem that we have that might have something to do with this problem. So right now, I had an idea for what it was. Hold on. So hold on. I got to do this again because redo. Because I totally thought of something. That's actually really cool. Except for the fact that it will eventually just become a line, kind of. Oh, yeah. Really important thing. So we actually didn't hit apply when we changed our wind angle to be really strong. So let's see if that makes a big difference. All right, let's try 500. Well, actually, we need to stop. 500, apply. All right, well, let's just put it back to a reasonable value. I mean, it kind of looks like wind. I want it to be less rustly. Oh, I see the problem. So rotate towards. Okay, so this is the problem. So rotate towards is taking the original rotation and then rotating an amount, but we're not actually getting towards the goal rotation because we're always starting at the original rotation when we do this. Okay, that makes sense. So we actually do want to have our transform.rotation here, but we also want to somehow limit the amount that it can rotate towards the goal rotation vis-a-vis our original rotation. So we don't actually want. Okay, so here's what we actually want. We need a interim here. We need quaternion max goal max rotation equals, we're going to do quaternion.rotate towards here. We're going to use our original rotation in this part, original rotation, and we're going to use goal rotation there, and we're going to not do random.range. We're just going to do straight up wind angle times time.delta time. Actually, not just wind angle. And then what we're going to do is we're going to use max rotation instead of goal rotation here. And this time we'll go ahead and do exactly that. And let's see what this does. Save. This might actually be cool. Maybe. Or it might be horrible. Or it might not compile at all. Oh, it helps to spell quaternion. I missed an N. Not an M, an N. Save. Play. There we go. Kind of. Oh, that tree's seriously getting bent out of shape. We've created some interesting creatures, certainly. Not really trees, but creatures. It's more like a sun angle thing. Like if you've watched time lapse of like plants and stuff, they try and bend towards the sun. That's kind of what we've created here. So let's make it so that the wind angle is considerably less now. Let's make it 10 degrees and hit apply and see how that looks. Okay, so the ones where it spreads are the ones where the wind's going in a direction that that's like blowing straight down or blowing straight up. This is actually much closer to what I was actually expecting to get out of this. So yay. So let's explain what just happened here. So what was happening before is we were basically jittering from the original rotation to the max rotation by a random.range here. Basically, we're just taking this angle here and just kind of going, hey, go that way, and then oh, go back towards the original a little bit. Oh, go back towards the goal again. This time, what we're doing is we're creating a rotation based on the wind angle, and the original rotation, and then we're changing the transform.rotation to move towards that max rotation by a random amount, based on the wind angle, and so that that makes this a little bit smoother. There's probably a couple more variables we could add to this, and we could do more to make it look a little bit better. But I'm going to actually save this at this point. I'm going to do one more thing. I'm just going to, just because we're already over time anyway, I just want to make it a metal tree because metal trees are cool. Metal tree. And we will just throw this into our folder. And our twig cube, we're just going to make this fully metallic and real shiny and throw it onto our cube and hit play. There, now we have a metal tree. Okay, that's too metallic. Hold on. Does it look better when it's a little bit more smooth? Yeah. Less smooth, I mean. Maybe a little less metallic. There we go. Cool, metal tree. Save scene, save project. I'm calling it. Sorry it took so long. Anyway, thank you for joining us for this exploration on random rotations. Hopefully you enjoyed it. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfyre, that's DRAKFYRE. And thank you very much for watching. And you guys have a great one. I will catch you tomorrow with another Breakfast with Unity, which will be something else. We'll do something else. I don't know what it'll be. It's exciting. See you guys. And girls. See everyone. Alright. So, Unity.rocks. Let's see if we actually broadcast anything. This is the most exciting part of the show, when I find out that if I've been talking to nothing. Or that I forgot to... Oh, please tell me. Please tell me I did switch the camera on. Alright. Oh, I did. So, woo! Alright. Is it possible to make the tree in a single mesh instead of separate branches? Yeah, we could generate a mesh based on this. Although, if we generated a mesh like that, you wouldn't be able to animate it. You also could, after the fact, use combined mesh to create a single mesh from it. And again, you would be limited in the animation options for that. So, and the foreman just mentioned mesh combined as well. And it would also be hard to animate using the current approach. Yes. The nice thing is these things do actually batch, at least to a certain extent. They really should all batch, but for some reason, I guess each iteration just gets its own batch. So it's not like these things are being treated as a separate model ultimately by the renderer. Of course, there is still object overhead. Like each of these has, object overhead for existing. They have to be created. They're tracked by Unity. But yeah, it yeah, I like this. I actually kind of like how it turned out. I was panicking there for a bit in the middle. So yeah, and I'm just going to go ahead before I forget and check this stuff in. More tree action. Anyway, thank you guys for joining us, and you guys have a great one. Oh, yeah. Oh, yeah. Very good point, actually. I didn't remove the box colliders, did I? So this is actually a tremendous performance problem here. For two reasons. One, it's a box collider, so we don't really need the collision, and yeah, that's horrible. But two, we're animating it, and it doesn't have a rigid body, which has an additional cost. So, matter of fact, there really should be a warning for that when that happens in the game. Like, it should just give you a debug log warning, spam, just being like, you moved an object that didn't have you moved an object that has a collider but doesn't have a rigid body. So yeah, if we wanted to fix that, we could just go remove component, and now we don't have that physics overhead. But I mean, it still was running just fine before. Let's actually see. So CPU 8.1 milliseconds, 6.8, somewhere 8 average. And then if we undid our change, which I evidently can't undo, well, I don't care anymore. Oh well. Anyway, yes, that is a very astute observation. Anyway, see you guys around. How do I stop this thing again? There we go.